Okay, welcome to this video. We're gonna do this question 8 from a May 2010 paper, and it's on calculus. They give you some information here about the nature of the derivative of the function. There it is. That is the second derivative. You can't really see the two dashes there, but that's the second derivative of the function, and it says that it's 3x minus 1, so we can write that down here. Make sure we don't get confused. 3x minus 1. Okay, what other clues do they give us? They tell us that the graph of f has a minimum point at a, 2, 4. So there's a minimum at point A, which has coordinates of 2, 4. That's a minimum. And then there's a maximum at B, minus 4 over 3, and then this ugly fraction right here. Okay, that's all the information they give us. We can use all of these clues to solve the problem. And then in part A they say, use the second derivative to justify that B is a maximum. So this guy here is supposed to be a maximum, and we need to use the second derivative, which is that there, to prove it. Before we do this, we need to remember a few things about maximum and minima, and the meaning of the second derivative and the first derivative. So let me do a little aside here for the moment. It's a really bad line. Okay. So let's say that this is our function. Okay, and this is f of x now. So this is x. The meaning of the first derivative, I'm sure you know already, is just the gradient, so, or the slope. So here the slope is positive, here the slope is 0, here it's negative, here is 0, here is positive, and here it's approaching. And if this turns all the way around, then here there's another 0. Right, so we know the meaning of the slope being 0 always happens at maximums and minimums. What about the second derivative? What's the meaning of that guy? So the second derivative, the same way that the first one is the way that the function itself is changing, the second derivative is the way that the first derivative is changing. So what do we mean by that? Well, if you look at the slope here, it's really positive, and here it's less positive, and here is 0, here is more negative, and then here is even more negative. So we could say that for this function, between this point here and really this point here, the first derivative, in other words the slope, is getting more and more and more negative all the way. It goes from very positive to less positive to 0 to more negative to very negative. So for that whole region, we could say that the first derivative is getting more and more negative. Therefore, the way that it's changing, which is this thing here, is going to be negative. So the value for that second derivative is smaller than 0. It's negative from there to here. From here onwards, the function is starting to get a little bit, it's kind of recovering. Here it's very negative, here it's a bit less negative, here is 0, a little bit more positive, really positive. So for that whole region until here, approximately, it's getting more and more positive. So we can then say that for that region, the second derivative is bigger than 0, positive, for that whole region. And then here again it's getting more and more negative, so therefore here, from here to here, the second derivative is smaller than 0 because it's getting negative. It's getting more negative, more negative, 0, more negative, more negative, more negative, more negative. So That means that we can use the second derivative as a clue to find out if a function is varying as a maximum or as a minimum. Because for this whole region here, that's called a maximum, right? Because it's a hump. For the whole region, the second derivative is negative. For this whole region here, which is a minimum, the second derivative is bigger than 0, it's positive. So it's counterintuitive. Okay, for maximums, second derivative is smaller than 0, and for minimums, it's bigger than 0. Why does that help? Well, because in the question they're asking us to show that this point over here is a maximum. In order to prove that that's a maximum, all we need to do is to put the value of x, forget about the value of y for now, the value of x, we put it in here, which is the expression for the second derivative, and since we want to prove it's a maximum, we need to show that the answer is negative. If the value is negative, we show that it's a maximum. Notice that they've told us already that these are turning points. So this is a minimum here and this is a maximum, right? They've already told us that. So we know that it's a turning point. We know that B is a turning point already. So if B is a turning point, for it to be a maximum and not a minimum, this needs to be negative. So let's try that now. We put this value for x into there. So 3 times minus 4 over 3 minus 1 is equal to minus 4, because the 3's cancel, minus 1, which equals minus 5. Therefore, you can just say that because the second derivative is negative, this implies that it's a maximum. And that's it. That's all the marks for that question. It's really a simple thing to do, but it just took me a while to explain why it works in that way. But if you just did it straight away, it would take you literally 20 seconds. Sorry about the zooming. Okay, part B gives us this information here. They give us an expression for the first derivative, it's kind of a clue, and then they ask us to find P is minus 4. Now hopefully you can see that because they give us the second derivative and they want us to show something to do with the first derivative. In order to go from the second to the first one, you've got to do an integral or an antiderivative, right? You've got to integrate it, and then you get an expression for the first derivative. Then we need to show that P is minus 4. So this is the clue they give us. Let's see what we get if we integrate the second derivative first, and then see if it looks anything like that. I'm going to just rub a few things here so we can keep everything in view. Okay, let's see. So the second derivative, I don't need red anymore. I'm gonna go back to white. They gave us that the second derivative is equal to 3x minus 1, right? So if we want to find the first derivative, it's the same as the integral of the second derivative, dx, right? Hopefully that makes sense. You don't have to write that line, but it's just to be mathematically correct. Now that would look like the integral of this expression here, 3x minus 1 dx. So we integrate that guy. X must go to x to the 2, right? From x to x to the 2. And then we need a 2 underneath to cancel with the 2. And then the 3 was there already. So if we differentiate this to check, we see that the 2 comes down to multiply, cancels with this 2, and I'm left with 3x to the 1 because I subtract 1 from the power. This is what I had before, so that integral is well done. Then the integral of x, remember that minus 1 must come from an x. Okay, when you differentiate, constants disappear, but when you integrate, constants don't disappear. Numbers, they have an x, because now if I differentiate this, I get minus 1, which is what I had before. So that's how to check if you've done how you can check if you've done the integral correctly. You just differentiate it again. Now, what am I missing? The integration constant, which normally we call c, right? But if we look at the question, we've got 3 over 2 x squared, 3 over 2 x squared, that's looking good, minus x plus p. So they've actually given you a different letter for the c. Instead of using a c, you just use a different letter, which is a p for the constant. And they ask us to show that p is minus 4. How can we find out what the value of p is? Well, since this is the first derivative, right, we can't use the values for the x and the y coordinates here, because that would be true for f of x, but we don't have f of x, we have f dash of x, so we can't use x2 and then y equals 4 as our values. What we can use is information that they've given us in the question about the slope. What have they told us? That the minimum happens here and the maximum happens here. So we can use either one of both, and actually I'm going to use A for now. And what we do know is that the slope at the minimum, right, at any minimum down here, or at any maximum, has to be 0. So that is our clue. We just say, well, if f dash of x has to be 0 at either of these points, then I can just put in the x coordinate into what I just worked out and make it equal to 0 and figure out what p is that way. So if you make 0 equal to this here plus p, and then you put in a 2 in there from that coordinate, because we know that there is a minimum at 2, this 2 here, we put that 2 in there, we'll be able to figure out what p is, and hopefully we'll get the minus 4 that they asked us to show in the question. So let's see what we get. 0 equals 3 times 2 squared is 4, divide everything by 2, there's a multiplication there, let's not forget, that's minus 2 because x is 2. Here I'm just putting the 2, remember? And then here plus p. So that needs to be true. So let's see, 3 times 4 is 12, divided by 2 is 6, 6 minus 2 is 4, 4 plus p needs to be equal to 0. Therefore, p has to be minus 4. And we go back up to the question, and we see that indeed p is minus 4. So that worked out fine. We could have equally used this value of x, because that's also a turning point, it's also a maximum. But I chose to use that one just because I prefer whole numbers than fractions. But you could have used it the other way around. You could use this one now to check if you've done it correctly if you wanted. But perhaps better to leave that check until the part C of the question. Okay, I'm going to do a little bit of rubbing here because yeah, I'm not going to be able to rub there. It's going to go black if I rub. Okay, so now the last part. Now, what I would like you to pay attention to, especially with views towards exam technique, is that in part C, they ask us to work out f of x, but in part B, they gave us a piece of information that's really valuable. They basically did it for us in case we were not able to do part A. So if you cannot do the part A of a question and the second one has a given that, you are totally allowed to use the information they've given you in the exam to do part C. So don't give up if you haven't been able to do the part A of a question. You just take whatever they gave you in part B and you can take it from there and continue with the part C. Hopefully that makes sense. You can just take this, and since they're asking you for f of x, and here they essentially gave you f dash of x, all you've got to do there is to integrate this whole expression, putting in the value for -4, and you can get your f of x, so you can still get the marks for part C. So let's have a go at that one. Okay, part C. To change my pen. Part C. Well, if f dash of x equals 3 over 2 x squared minus x plus p, and p is -4, plus -4 is just -4. So be careful there. Now, if I want to find f of x, that's going to be equal to the integral of f dash of x dx, which equals the integral of 3 over 2 x squared minus x minus 4. All of that with respect to x. So then f of x will be the integral of all of that. Oh, sorry, it's kind of tricky to move this thing sometimes. Okay, so how do we integrate that guy? Well, the x is going to go to x cubed, that's for sure. And then I'm going to have to divide by 3. So I already divided by 2. So if I divide by 3, I'm going to get a 6 at the bottom. Because 3 times 2, they multiply at the bottom and I get a 6. Another way of seeing it is that I already had a 2 there. I now multiply by 3, I can leave it like that. And on the top I had a 3, so I'm going to keep that 3 there. If I now check and I differentiated this, the 3 would come down, cancel with this 3, and then this would go down to a 2, and I would have 3 over 2 x to the 2, which is what I have here at the beginning. So that integration is done properly. That's how I always check if I've done it well. I just differentiate again. X goes to x to the 2, which means I need a 2 underneath, and -4 goes to -4 to the x. That's all done, and then I need one constant, which I'm just going to call c in this case, or d, doesn't matter what you call it. And so I've nearly finished now. All I need to find out is the nature, or the value of this constant here. Let's first tidy this up a little bit because it's really messy. This 3 is going to cancel with that 3, and I'm going to get x cubed over 2. And I have here x squared over 2, and here minus 4x, and this plus c. Now, this is f of x, so I can actually use the values that they've given me. This is a mess, sorry about that. I can use the values they've given me, either this one here or that one there, to find out what the constant is, because I know that according to the information they give me, point A has a value of 2,4. In other words, when x is 2, my f of x, f of 2 must be 4. The value of the function, my y, must be equal to 4, my y coordinate. So I can use that information to figure out what the constant is. It's getting really hard to maneuver this. Okay, so let's do that. The answer must be 4, the y coordinate must be 4, so I'm using this point here, 2,4. Y coordinate must be 4 when x is 2. So 2 cubed is 8. 2 times 2 times 2 over 2 minus x squared is 4 over 2 minus 4 times 2 plus c. All of that must be equal to 4. Okay, I'm using that point there. So 8 over 2 is 4, 4 over 2 is 2, this is 8 plus c, this is 4. So I pass everything to the left hand side. But let me simplify this first. 4 minus 2 is 2, 2 minus 8 is minus 6. So minus 6 plus c is 4, therefore c has to be equal to 10. And I pass the 6 to the other side. And that's the whole question done. Vale. Thank you very much. I hope that was useful. Yeah, please pay special attention to the exam technique tricks, guys, because if if you just don't do part C because you didn't know how to do part A, that's such a big shame, because in B they give you the information you need, so you can pick up a whole bunch of marks by being sensible there. I know lots of students who just give up on a question because they can't do the first part, and whenever they give you a given that, use the information they give you for the next parts, because you might be able to do those. There are different skills that they're testing. All right, see you in the next video.